In this example, we are going to consider two loops. The first loop is 1 O and 2. 1 O 2. First one, voltage V1. For this resistance, it is going to be IR1, and as the current is flowing in the direction of the loop, that's why it is going to be negative, minus IR1 minus current flowing in the second branch is I2R2, and that's why it is I2R2 minus V2 is equals to 0. Now we are just going to put out that values, and simultaneously for the second branch we are going to consider is V1, 1 O and 3 as shown in the figure. 1 O and 3, and again we are going to derive one equation for that. V1 minus of IR1 for this one. For this one it is going to be minus of I1R3, and for this one it is V3 is equals to 0. Now we are going to put out the values, and that's why we are going to have one equation. 5 is equals to 10I plus 30I1, and another equation that we have is 4 is equals to 10I plus 20I2. Now we want to evaluate the value of I, and that's why we are going to use elimination method and junction law. We know that I is equals to I1 plus I2. I is equals to I1 plus I2, and that's why we are going to put out the values. And if we are solving both these equations, we are going to have the value of current I, that is as a 0.2 ampere. Here we have to find out the value at a point O, what is going to be the voltage, and that's why we are going to consider that loop, that 1 R1 and O, 1 R1 and O, and that's why we have a value of V1 minus IR1 minus VO, that is equals to 0. V1 is 10, I is 0.2, R1 is 10, that is equals to VO. That's why we can say that VO is equals to 8 volt.